Let's play with the multiplication rule for conditional probabilities, and this is with an algebraic approach, meaning we're going to use symbols and formulas. So, conditional probability, this is kind of important to understand. We are finding the probability of an event happening given that another event already happened. So this is not just saying what's the probability of me picking a green pencil out of a bag. Nope. This is saying what's the probability of picking a green pencil given I've already pulled out 6 blue ones. Okay, so something else has already happened, which is changing the conditions of what I'm doing. Okay, so the notation. With this being an algebraic approach, we've got formulas to play with. So first of all, note this P with a parenthesis, A, line B. This reads the probability of A given B has occurred. Okay, and I make this a big point to say this because you're going to do problems that aren't going to be in the notation of A and B. And so you're going to have to say, okay, based on what I have, can I put this into notations using words, right? So you have to really understand. Now look at this formula. Probability of A, lost my pen. Probability of A given B equals the probability of A and B. So A given B, A and B. And then in the denominator, I'm dividing by B. I'm dividing by the event that has been given. That's important to note, okay? Now, we could rearrange this formula. We could manipulate the formula. And we could also say that means the probability of A and B equals the probability of A given B times the probability of B. Again, now we're multiplying by the probability of what has been given, what has already occurred. Make note of that. That's important. Okay, so a little hint. I know that a lot of students that I've worked with in the past, they want to do everything in their head. They want to do everything on a calculator. They don't want to write anything down. Listen, it's going to be so much easier if you write it out in symbols first, symbols that match your problem, and then substitute in the numbers. You will make fewer mistakes, okay? Write it down. Let's do an example. We're going to do 2 examples, so just bear with me. The probability a randomly chosen student is in calculus is 1 out of 35. The probability a randomly chosen student is in calculus and physics is 1 out of 150. What is the probability that a randomly chosen student is in physics given that the student is in calculus? I know some students will read this question and go, I don't know, I'm moving on to the next one. But don't let that be you, okay? This is where I say, write down what you know, okay? I know the probability of a student in calculus is 1 out of 35. Write down what you know and use symbols that make sense to you, okay? Then the next, the probability random student probability is in calculus and physics. Now, one thing I want to note is calculus and physics or physics and calculus is the same thing, okay? Because it's an and, both are happening, is 1 out of 150. What is the probability that the randomly chosen student is in physics given that the student is in calculus? This is what we are trying to find out, okay? So write this out because then you can say, okay, I know I can use this formula for that. So let's go ahead and write out that formula. The probability of physics given calculus, well, that would be the same as the probability of physics and calculus, right? All over the probability of calculus. Because whatever is given, that's what you're dividing by. Now we can plug in what we know, right? So I know probability of and is 1 over 150, and then we're going to divide by the probability of calculus. Now we get to practice our dividing of fractions, right? This is like a division bar. So 1 over 150 divided by 1 over 35. In case you have forgotten, because if you don't use it, you lose it, to divide fractions. Our first fraction stays the same. I don't like that color. First fraction stays the same. Division turns to multiplication, and we flip. We multiply by the reciprocal. Okay, so 35 over 150, because we would just multiply straight across. If we reduce both by 5, right, because both of these are reducible by 5, we get 7 over 30. So the probability of physics given calculus is 7 over 30. Let's do one more example. The probability a randomly chosen student plays a sport is 0.32. The probability a randomly chosen student is in the orchestra is 0.08. The probability that a randomly chosen student plays a sport, given they're in the orchestra, is 0.02. What is the probability a randomly chosen student plays a sport and is in the orchestra? Okay, so let's see what we know. Probability of somebody playing a sport is 0.32. Randomly in the orchestra is 0.08. Chosen student plays a sport, given they're in the orchestra, is 0.02. I don't know why my lines get so long. I get excited, I think. And so now we're trying to find probability a chosen student plays a sport and is in the orchestra. That's what we're trying to find. Okay, so we can use our formula. Now let's go back to where we were from the other page. And we say, okay, I'm trying to find sport and orchestra. So I know probability of sport given orchestra. So what am I multiplying by? I have both of these. How do I know what to multiply by? Well, remember, it's whatever you're given. Sport given orchestra. So that means we're going to multiply by the probability of orchestra. That's why it's important to pay attention to what you have and what you're dealing with here. Okay, let's plug in what we know. So I know that sport given orchestra is 0.02, and I know the probability of orchestra is 0.08. So when I multiply those together, the probability of sport and orchestra is 0.0016. Write it down, see what you have, plug in what you know. It'll make it easier.